Hello students, in this lecture we will do this problem. Problem is already on the screen, you can read once. So the problem is find the position vector of R which divides the line segment joining capital A and capital B. These are the points whose position vectors are small a and small b respectively in the ratio m is to n internally. Okay, question is there is a line segment. Okay, there is a line segment. Let me make the line segment for you. Suppose this is your line segment. Let's call the line segment the name given as A and B. Okay, this is the line segment A and B. Now this line segment is divided by one point R. Okay, this point R anywhere you can take. Suppose this R point is here in the ratio m is to n. So this is m, this is n. Okay, then we have to find the position vector of R, this point. Okay, so when we talk about position vector, it means we should take the vector from origin. Okay, so let's assume here somewhat any origin. So if I join these two, O to B, okay, and this O to A as well. Okay, this situation. So this is my O point. I need to find the vector OR. This. Okay, I need to find this OR vector. This we can do by simple the vector law of additions. O A vector, O B vector. This is origin O. So little bit construction we have done, so we can write some language solution from start from here. Okay, so firstly we write let already given small a vector is the position vector of point A. Let small a vector is the position vector of point A. Okay, let me shift this figure somewhat little right. Okay, now it's fine. Position vector of point capital A. Okay, similarly I can write B vector is the position vector. B vector is the position vector of point B. Okay, and similarly let small r vector is the position vector of point capital R. Okay, so we need to find the value of R in terms of A and B. Okay, fine. Now you can see from figure, from figure we can write AR vector upon RB vector. देखो AR vector upon RB vector, they are collinear vector, so they will be scalar multiple to each other. So I can write AR vector upon RB vector same as M upon N. Okay, see this AR vector, this R vector upon RB vector is M upon N. You also know if O is a position vector, and if you want to write AB vector, you can write OB vector minus O A vector. Okay, this concept OB vector minus OA vector. Similarly from here, how can I write AR vector? If I involve this origin O, it means I can write OR vector minus OA vector, and here OB vector minus OR vector and M upon N. Now I will put the values. OR vector, Andre, OR vector means small r vector minus OA vector is small a, OB vector is small b, OR vector is small r equals to M upon N. Now I can cross multiply. So this into this, N into R vector minus A vector equals to M into B vector minus R vector. Simplify N R vector minus N A vector, M B vector minus M R vector. Now I want position vector of r, so r I will shift on the left hand side. So this mr vector shift to left hand side. Mr vector plus na vector equals to mb vector, and this shift right left hand side or right hand side, and a vector. Now here this is r vector, okay, and r vector, this is here, this is n r vector. Now r vector is common, so here m plus n equals to mb vector plus n a vector. So from here, what is r vector value? R vector value is mb vector plus n a vector upon m plus n, and this is the position vector of r such that capital R divides the long segment joining A to B in the ratio m is to n. So this is the required formula for internal division, okay, for internal division. If you want to learn the formula for external division, just let me know in the comment box. I will make the video on that also.